Here we go, guys. We're going to explain this practice quiz 2.6, which you shouldn't really even need because you have all those videos on the lessons and the problems we did throughout the week. But here it goes anyway. Let's look at number 1. It says find f of 2. This is a fill in the blank. This is function notation telling you to plug in the number 2 into the x. Now, of the f of x function. Here's the f of x function. Here's the machine. The question is, which one do we use? Do we use the top one or do we use the bottom one, the x minus 1? That all depends on your condition. You're going to use the top one if your x value is less than 2. As you can see, this is 2, and 2 is not less than 2. 2 is equal to 2. So the bottom one says to use this bottom one if x is greater than or equal to 2. There's the or equal to part. So we know we're going to be using the bottom one. So all we need to do is take the number 2 and plug it in right here. 2 minus 1. 2 minus 1 is equal to 1. There's your answer. Let's move on. Number 2, and of course on your practice quiz, the questions will be mixed up. I'm focusing in on the function notation of these piecewise functions of plugging in the certain inputs that they want, the certain x values that they want. So right here it says to plug in the x value of -4. Where are you going to plug it in? Are you going to plug it into the top one or to the bottom one? It's the same f of x function, just a different input. -4 is definitely less than 2. So because -4 is less than 2, we're going to be using this top one, the 2x. So if you want, you could show your work by writing 2x, but instead of x, you put parentheses, and then you could plug in that input value, and 2 times -4 is -8, and there's your answer for number 2. Let's try number 3. G of 7. Okay, we're going to plug in the number 7. Where do we plug it in? Well, we're going to plug it into the top one if 7 is less than -1. 7 is not less than -1. We're going to use a middle one if 7 is between -1 and +1. 7 is not between -1 and +1. We're going to use this last one, x, if your 7 is greater than 1. So it is greater than 1. 7 is definitely greater than 1. So we're going to simply plug it in, and we are plugging it in, and most of the time we have like interesting functions, like let's say 2x minus 7 or 1/2 x plus 4. Right here it's just x. So you are plugging in the number 7 into x. So if you plug in the number 7 into x and there's no math to do, what's your answer? It's simply that number 7, right? So g of 7, if your equation is just x, y equals just x, plug in the 7 and your answer will be 7. Okay. Number 4. G of 0.5 is g of 1/2. So where is 1/2? Is 1/2 less than -1? Absolutely not. Is 1/2 between the -1 and the +1? Yes, it is. It's between them. So we're going to be using this middle function, okay? Actually, let me just highlight this for you. We're not using this blue one. We are using the red one, and we're definitely not using that yellow one, okay? So what we're using the red one, I'm sorry, and notice that when we know which one to use, after that we need to plug it into the x, and there is no x, it's just the number 0. So what does that mean if there's no x? Who cares what your input is? That will be your answer. So the answer is 0. The answer is 0. Now again, if I would have had a 7 without an x, then it would just be 7. If I'd have a 2 without an x, the answer would just be 2. Now, if I had a 2 with an x, then I would plug in my 0.5 and say 2 times 0.5. If you have an x, that's when you plug it in. If you just have a number and no x, then you don't have to plug anything in. That number will be your answer. Moving on. State the domain and the range of the above piecewise function. Again, the domain are your x values. That means you're looking at it left and right, okay? And if you're looking at it, if it's going to the left, then that is a less than symbol. If it's going to the right, then that is a greater than symbol, right? Now, if it were to say range, then range, that's up and down. The range is up and down. So obviously if it's up, it's greater than, greater. If it's going down, it's less than. So that's how we come up with these domains and ranges. So when we look at this entire piecewise function, not just one piece of it, but all 3 pieces of this piecewise function, does it go to the left forever? Yes, it does. Does it go to the right forever? Yes, it does. So since it goes to the left and it goes to the right, it's going both directions. That means that x equals all real numbers. So our answer for domain, x equals all real numbers. How about the range? The range are your y values. That's your up and down, right? I mean, this is after all our y-axis, which goes up and down. Now, does this graph go up forever? Well, if it had an arrow here, it would, but it's an endpoint right there. So it ends. This is the highest point. Okay, and does it go down forever? No, it doesn't. There's an endpoint right there. That's the lowest point. So your highest point is at the y value of 1. Your lowest point is at the y value of -3. And that's key to understand, or how to write your compound inequality that represents your range. You're going to put the y in the middle. You're going to put your smaller number, -3, on the left side, your bigger number, +1, on the right side, and you always put less than symbols. Now the question is, which one is a solid dot? There's a 1, there's a solid dot, there's a -3, that's an open dot. So obviously no solid line underneath the -3. You do want a solid line underneath that inequality between 1 and y. Why? Because it's a solid dot up there, so you need a solid line down there. So there's your domain, there's your range. We're ready to go to the next question. State the range of the above piecewise function. Only the range. What is range? Range is up and down, right? If it's going up forever, then that's y is greater than a certain value. If it's going down forever, it's y is less than a certain value, okay? So the question is, does this go up and down forever? Not just looking at one piece, looking at all 3 pieces. And notice this guy's not going up, right? If it had an arrow going up, then yeah, it would be up and down forever. So you would say, you know, well, that's not the case, is what I'm saying. Right here, it's from this point down. And this goes down forever. Even though it goes to the left, it goes down forever. And this one also goes down forever. If it were going up, like if this one were going down and this one were going up, then yeah, range would be all real numbers. So y equals all real numbers. But we know that that is not the case here. They're both going down. So where does this graph start existing? It doesn't exist at y equals 5. It doesn't exist at y equals 4. It starts existing at 3. And all of your piecewise function is below 3, of course, with no gaps. So your range, they're asking for range. Your range is y is less than or equal to 3. Again, solid dot at 3, that's why there's a solid line underneath. Moving on. State the domain of the above piecewise function. Domain, left and right, pretty clear. That it's all real numbers, because this does go to the left forever, it does go to the right forever, and there are no gaps. Just for the future, what do I mean by gaps? You see how there's an open dot here and there's a solid dot there? There is no gaps, right? At the input of 0, the output is not 0, the output's -1. At the input of 1, the output is 2. Right? At the input of 2, the output is not 3, it's actually 4. There are no gaps. So if I had an open dot right here, then there would be a gap right there. So you would have to say x equals all real numbers, but it could not be 0 if there were 2 open dots. But that's not the case here. Again, it goes to the left forever, it goes to the right forever. The domain is x equals all real numbers. Moving on. State the range of this guy. Well, does it go up forever and does it go down forever? If it does go, like if I had an arrow going up and this one arrow going down and it goes up and down forever, I would say y equals all real numbers. That's not the case here. It's going up, 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 then bam, endpoint, it ends right there. So this is the highest y value of the entire piecewise function. That y value is 4. Everything about this piecewise function is below that y value of 4. So my range is y is less than or equal to 4. Now you might be thinking, well, it doesn't go down forever. Look, this one stops right here, so there's nothing down here. Yeah, but what about this guy? This guy does go down forever. Even though it goes to the right, it does continue to go down forever. So it is a true statement that y is less than or equal to 4. If this guy would have been horizontal going that way, then yeah, it would be between 4 and -1, and you would have to do a compound inequality with the -1 on the left side, the +4 on the right side, with the y in the middle with less than symbols, less than or equal to, because they would both be solid dots. That's if this were perfectly horizontal, not going down, but it does go down, which means that this does go down forever, and that means y is less than or equal to 4. It does go down forever. Moving on. Number 9. State the range of the above. Range, again, up and down, right? So we're talking about y values, and we do see that the lowest point is at 1, And the entire piecewise function does go up forever. It goes up forever, right? So we say y is greater than that y value of 1. And I shouldn't have put or equal to because those are open dots. So just y is greater than 1, not or equal to. They're both open dots. Looking at this one, there are no instructions, but you should understand, hey, you got a piecewise function here and you got a bunch of piecewise functions down here. Which one is the correct one? I highly recommend you do this. Don't look at these guys yet, okay? Let's just zoom in just to the equation. I would make it big on your screen, and on your piece of paper, I would look at this graph from left to right, and I would start writing the y equals mx plus b equations of these pieces. Right? So do you have an m from here to here? Yes, you do. You go up 1 over 2. So we know that our equation so far is y equals up 1 over 2 x, and we need a b value. So where does it cross the b value? Up 1 over 2, up 1 over 2. Oh, it crosses right there at the value of 2. So this would be plus 2 right there. Okay, that's your first equation. I'm going to make this one in blue, right? Okay, let's look at the next one. This next one has a solid dot right here. And what is the slope? It looks like it's going down 1 over 1, down 1 over 1, down 1 over 1, right? So we know that this so far is y equals down 1 over 1 with an x. Now we still need the b value, and obviously the b value is the y-intercept, which happens to be at -3. So this is a -3 right there. And now let's go for the last one in red. What is the slope? Well, from here to here, it's going up 1, 2, 3 over 1, up 1, 2, 3 over 1. So we could clearly see that it's y equals up 3 over 1 with an x. But we also need a b value. And to think about that b value, you got to extend it in the other way using the slope pattern. You're going up 1, 2, 3 over 1, going backwards over 1, down 1, 2, 3 over 1, going down 1, 2, 3. You're 1 unit off. If you want, go ahead and put a dot right there. And let's think about what that y-intercept is. -1, -2, -3, -4, -5, -6. So the b value is -6. So our equation has a -6 at the very end. Ladies and gentlemen, we have our 3 equations. We have our 3 equations. Y equals 1/2 x plus 2. Y equals, I would just say -x minus 3. And over here, y equals, I would just say 3x minus 6. So on your piece of paper, you should write out your pieces, your piecewise function, f of x, and you put your giant brackets. The first one is 1/2 x plus 2. Now you got to think of the condition. Where is this at in terms of your x-axis, this blue one? The condition is, it looks like it's at -2, it's an open dot, and it's to the left. Left is less, greater than is great. Okay, so left is less. So we're going to say if your x values are less than this x value of -2. So that's what we should write, if x is less than -2. Moving on to the green one here, this green one. Y equals, I want to say -x minus 3, okay? Y equals -x minus 3. And now what's the condition? Well, the condition in terms of your x values, where are these endpoints at? You got to look at your endpoints and look at the x number line. Where are those x values? It's -2 and +1. Again, -2 right here, -2 and +1 right there. -2, +1. So I'm going to write down those numbers. I'm going to put if, and I'm going to put -2, I'm going to put +1, I put the x in the middle, and I put less than symbols. After that, I worry about, did I have open dots right here and here, or are they solid? They're both solid, so they both need solid lines underneath your inequalities. Last but not least, we have this red equation, y equals 3 over 1x minus 6. I'm just going to put 3x minus 6 if, now what's the condition here? Look at your x-axis number line. Where does it start existing? It starts existing right here. That endpoint, that open endpoint, is at the x value of 1, and it is, where is it, to the left or to the right? It's obviously to the right, so that's greater than 1, if x is greater than 1. And it's an open dot, so you don't put greater than or equal to, it's just greater than the x value of 1. So if x is greater than 1. And ladies and gentlemen, that is your piecewise function explained. I would do that on paper and then try to find that right here, right there, and so on and so on. And the multiple choice in this particular one, none of these are correct. you will not find all of these details. You will not find all those details down there on the multiple choice. Okay, so again, I highly recommend you write it out on paper first and then look for the correct answer. Another piecewise function, and of course we need to identify which one it is. I highly recommend, again, just making your graph big, getting your piece of paper, asking yourself, what is the slope of this blue one? Look at from left to right, right? So this is the first piece we see. What is the m value? It looks like you're going up 1 over 1, up 1 over 1. So far this blue equation is y equals up 1 over 1 with an x, right? Y equals mx plus b. So far we have the y equals mx. The slope is up 1 over 1. Now, where would it cross the y-axis? If you continue going with that pattern, up 1 over 1, up 1 over 1, it would be right there at the b value of 5, right? The y-intercept of 5. So with the b value is 5, you're going to put a plus 5 right there, and you have your blue equation. If you wanted to, you could start writing your f of x function, right? F of x equals big giant brackets, and you could do that blue one up there already, x plus 5. You could worry about the condition later. Maybe we should do that this time. Worry about the condition later. Right now, let's move on to this next one. This is a horizontal line crossing the y-axis at 1. That should be the equation y equals 1, right? Anytime it's horizontal, it's just y equals a certain value, and that value that crosses the y-axis, which is y equals 1 in this case. Going for the last one in red, what is your slope of this pretty steep line? It looks like it's going up 2 over 1, right? So the slope is up 2 over 1. So I'm going to start writing my equation. Y equals up 2 over 1 with an x. What is the b value? You might be thinking, well, it doesn't cross the y-axis. Well, no, because you're only looking at a piece of it, but you got to think of the whole entire line. Where would it cross? Using that pattern of up 2 over 1 backwards, over 1 down 2, over 1 down 2, it would cross right here at -3. So your b value is -3. Your b value is -3. Let's write the green equation next right here, and then the red equation. So instead of y equals 1, here's the y, here's the equal. All I do is put a 1 right there, okay? And then instead of y equals 2 over 1 x minus 3, I'm just going to say y equals 2x minus 3. Here's your y, here's your equals, here is your 2x minus 3. All we need now are the conditions, right? Obviously, you can't see the whole entire line, y equals x plus 5, right? That would continue forever, right? So we just need the condition. What are your x values? Look at your x-axis, go to that blue line. Where's your endpoint on x? That endpoint is right here at the x value of -2, and it is to the left. So x is less than -2, less than or equal to, because it's solid. Okay, so go to the endpoint. What's that x value on the x number line? And it is to the left. So x is less than or equal to -2. So that's our condition for the first one. If x is less than or equal to -2. Now let's go to the green one. The green one, I like the green one. It's a compound inequality. It's between this x value and that x value. Now this value does have an open dot. This one has a solid dot. So this one will simply be, this one will not have a solid line underneath the inequality. But what is this x value? That's -2. What is this x value? It's +1. It's between -2 and +1 on the x. Again, between -2 and +1. So write down -2. So if, write down -2 and write down +1, write x in the middle, write both less than symbols. Again, you always put the less thans because you purposely put the smaller number on the left and the greater number on the right. Anyway, this one does need a solid line underneath it. That's the x value of 1. There's the x value of 1. It needs a solid line underneath it. And now we're ready to move on to the next one, the red one. Okay, this last one, y equals 2x minus 3. What is the condition? Go to your x-axis. Where does this red line start existing? That endpoint is at that x value of 1, and it's not to the left. That would be less than. It is to the right. That is greater than. And it's not greater than or equal to, because that's not a solid dot. It's just greater than. So we're going to say if x is greater than 1. If x is greater than 1. Ladies and gentlemen, that is your piecewise function. And if you look for it, it is right here. That's your correct option. Again, I highly recommend, I wouldn't just start looking at them, because if you start looking at them, you're going to get confused. I would just go about my business and start writing the equations of each, writing them down, and then going for their conditions, and you should be able to identify which one's the correct one. If you do that, you should be safe. Here's another one. Let's again just jump right into naming the y equals mx plus b equations. On this blue one, you could clearly see that if you're at that left point and you go down to this open dot, it's going down 1 over 2. So that equation is y equals down 1 over 2 with the x. And the b value, where would it cross? Let's extend it. Down 1 over 2, down 1 over 2, down 1 over 2. Now this is going to be weird because if you're here, then it would cross right there. And if you understand this, that's great. I promise I won't give you one of these on the quiz tomorrow. But I'm just going to put a little tiny blue dot to show you that that's where it would cross, right? If I go down 1 over 2 and I go down 1 and over 2, it would cross right there perfectly in the middle at the 1.5 b value, okay? So technically that would be plus 1.5, or you could do 1.5, or you could write it as a fraction. What is 1.5? That's really 3 divided by 2. Either way is fine. But you got to check your multiple choice answers to see if I'm using decimals or fractions. Anyway, that's the blue one. Like I said, if you wanted to, you could start your piecewise function f of x over here already. And that first one is the negative 1/2 x plus 3/2, or maybe plus 1.5. I don't know. Let's move on to the green one. From this solid dot to this open dot, you're actually going down 2 over 3. So far, that equation is y equals down 2 over 3 with an x. Y equals mx plus b. Where does it cross the y-axis? 1, 2, 3. It crosses at 3. That's a positive 3. So there's my equation, y equals negative 2/3 x plus 3. So for my next piece, it's y equals negative 2/3 x plus 3. Negative 2/3 x plus 3. Now, last but not least, from this solid dot right here up to this dot right here, it's actually going up 1 over 2. So far, my equation is y equals mx plus b. The m is 1/2, right? Y equals 1/2 x. Now, what is the b value? Where does it cross your y-axis? Nice and simple. It's positive 1 right there. So plus 1 is your b value. There's my equation. I'm going to write it as y equals 1/2 x plus 1. There it is, 1/2 x plus 1. Now we need some conditions on these three, and the condition is pretty much the domain of each piece, right? So let's go to the x-axis. Let's go to that blue one. The blue one's right here at that endpoint. What is that x value? It's negative 3. And is it going to the left or to the right? It's going to the left, which means less than. So if x is less than negative 3. Okay, so that's exactly what we're going to write. If x is less than negative 3. No solid dot, that means no solid line underneath it. How about this green one that is between this x value of negative 3 and that x value of 0? That's exactly what we're going to write if negative 3 on the left, 0 on the right, x in the middle, less than symbols, this one solid and this one open. Okay, so again, it's between the negative 3 and the 0. Let's write down if, put the negative 3, put the 0, put the x in the middle, put less than symbols, and then worry about which one's solid. We know that this one's solid, and that's at the negative 3. So go to the negative 3, put a solid line underneath that inequality right there. Last but not least, we have this red one with the condition being that, look at this endpoint, that's at the x value of 0. Is it going to the left? That'd be less than. This is going to the right, that'd be greater than. So greater than or equal to, because it's solid, at the x value of 0. So again, you would say if your x values are greater than or equal to 0. Ladies and gentlemen, that is your answer. Find that on your multiple choice and you should be good. Again, don't look at your answers. That's going to mess you up. Trust me, I took this practice quiz already and it messed me up. I tried to just find the answer. It's near impossible, right? There's too many factors to keep in your brain. So just work one problem at a time, write the y equals mx plus b equation, write the condition, and then compare your answer and find it on the multiple choice. Let's move on. We have another one right here, another piecewise function, and of course we're jumping right in, y equals mx plus b. From here to here, both solid dots, the m is 1/3. So you have so far in the blue y equals 1/3 x. What's the b value? You can clearly see that it's at 4. So 1/3 x plus 4. The green one, that's going to be from here, it's dropping down 2 going over 1 to get to there, and they're both open dots. So that's y equals dropping down 2 over 1 with an x, and the b value is clearly positive 3. So there's your green equation. And the red one, that one is, again, dropping down 2, so the rise is negative, negative 2 over 1 as well. So since we know the slope is down 2 over 1, we're going to start writing the equation y equals down 2 over 1 x. And what is the b value? You have to use that pattern backwards. Down 2 over 1 backwards, over 1 up 2, over 1 up 2. It would be right there at the b value of 2, at the y-intercept of 2. So I'm going to put plus 2 right here. Plus 2. And after that, it's just about stating the condition of each one. So I have f of x equals, giant brackets, the top one, y equals 1/3 x plus 4. Here we go, y equals 1/3 x plus 4. And the condition is it between a certain value and a certain value? No, it's going from here, endpoint, to the left. And what is that x value endpoint? That's the 0 and to the left. So if x is less than or equal to 0, because it's a solid dot, less than's to the left, greater than's to the right. So this is at the x value of 0, and it's less than or equal to 0. So you put if x is less than or equal to 0. Okay, the next one, the green, this one's a little more fun. It has an endpoint here and an endpoint there, and you got to think of the x values. This is 0, this is 1, so it's between 0 and 1. It doesn't exist out here or over there. It's between 0 and 1. This entire green segment with open endpoints are between 0 and 1. So the condition is if your x is between 0 and 1. Okay, so let's do that. First of all, the equation is y equals negative 2x plus 3. Y equals negative 2x plus 3. And the condition, we said, is if your x's are between 0 and 1. And yes, you put less than symbols. If you have solid dots, then you would put solid lines underneath the inequalities, but you don't. Last but not least, y equals negative 2x plus 2. I don't need the over 1, so let me write that down. Y equals negative 2x plus 2. Now it's time for the condition. The condition, obviously the endpoints here going that way forever. That x value is 1, and it's to the left, which would be less, or to the right, which would be greater. It's obviously to the right, so x is greater than or equal to that 1. So the condition is if x is greater than or equal to that positive 1. Moving on. This one's a lot nicer, a lot less work. It simply says, using function notation, for you to input the negative 3 into the f of x function. So where would negative 3 fit? Is negative 3 greater than 0? No, no negative number is greater than 0. So you're not using this bottom one. Is negative 3 greater than or equal to negative 3? Yes, the or equal to satisfies this, so we need to use this middle one right here. I'm going to highlight it in red. Here we go. We're going to use the negative 2/3 x plus 3. Now I'm going to rewrite it right here, negative 2/3 x plus 3, and now I'm going to actually plug in this negative 3. Now some people get confused in multiplying fractions times numbers. Hey, you could use a calculator, but it's not that bad. All you do is put it over 1, multiply the top with the top and the bottom with the bottom. So when I think negative 2 times negative 3, I will get a positive 6. When I multiply 3 times 1, I will get 3. So technically that becomes 6 over 3, and I still have the plus 3. All right, 6 over 3, 6 divided by 3 is 2, and 2 plus 3 is the answer 5. So for your input negative 3, you get the output 5. Again, you got to know which piece to plug it in based on the condition. And another important detail, guys, is that your input are your x values, your outputs are your y values. So if we were to graph this piecewise function, technically the coordinate negative 3, 5 would be on that graph of the piecewise function. Pretty cool, right? Likewise, if I wouldn't have given you the actual algebraic piecewise function, if I gave you the visual graph, you could also answer this just by going to the x value of negative 3 and seeing where your graph is at, which in this case, it would be at positive 5 on the y. We'll get to that in a future question. right now it says state the range of the above piecewise function. Again, range is going up and down. It's weird that we haven't had any that have all real numbers. If this dot were there and going up forever and this one down forever, then we could have something to the effect of y is all real numbers for a range. Wait a minute, we'd have gaps in them. Let's not even mess with that. The bottom line is this is the highest point. It is below, everything is below that highest point of 4 on y. So the range is y is less than or equal to 4. Moving on. Find h of -3. Okay, here, this is what I was talking about a couple of moments or a couple of slides ago. They want us to plug in -3, and you got to think of the condition where you're going to plug it in, to the top one, the middle one, or the bottom one. But then you're thinking, wait a minute, what the heck? I don't even have a piecewise function equation. I just have the piecewise function graph. Okay, so again, you need to truly understand that whatever you're plugging in, whatever they're asking you to plug in, you're plugging it into x, which would be your x value. And whatever you get out as an answer, that's your y value, your answer, right? This is your input, your answer would be your output. So if you don't have the function, it's even easier if you have the graph, because if you go to the x value of -1, 2, 3, where's your graph at? Is it up here? Is it way down here? It's at -3, your graph is right there on the y value of -1. I mean, if it helps you, you could actually put a dot right there and put the coordinate -3, -1. Now, what does that mean? That your input -3, that you put in -3 and you got out a -1. So what answer do you type in? You type in -1. That's all you do. Put in a -1, that's your answer. Boom, you're done. Another one. This one says plug in h of 9. And you're thinking, okay, I'm just gonna look where the x value at 9 is at. And then you're thinking, what the heck? 9's off the graph. How am I supposed to do this? Well, keep in mind, this guy is totally horizontal. It's totally flat. This is the y value of 1, isn't it? So it doesn't matter if I told you to find h of 2 or h of 3, which would also be 1, or h of 4, which will also be 1, or h of 5 will also be 1. If I tell you h of 9, what's your answer going to be? It's going to be up there at 1. So the answer is 1 also. Moving on. State the domain. Okay, this one, first of all, I apologize. It looks a little crooked, right? It is crooked. Let me try to straighten. How about that? That's a little bit better right there. Okay, so they want us to state the domain, and the domain are your x values. Now, most of us are going to think, oh, x equals all real numbers. And if you put that as a multiple choice answer, it's going to be wrong. What the heck? I thought it was all real numbers. Yes, it is all real numbers, but there's a gap, there's a hole, and you have to mention that it cannot be that value. You see, this one does go to the left forever, this one does go to the right forever. So it does go to the left and the right forever. However, open dot, solid dot, that's cool. Open dot, that means that there is no value. If you plug in -2 into your piecewise function, that you won't be able to get an output. It's an undefined output. It's not at 1 and it's not at -5 because those are open dots, okay? So what we need to say is, this part for sure, x equals all real numbers, but x cannot equal -2. Because at the x value of -2, there is no graph. It's just a hole and a hole. There is no graph at x equals -2, so we need to state this as part of our answer. But x cannot be -2. Last, is it the last one? No, we still got more to go. I think, I'm not sure. No, I think this is number 20. This might be the last one. It doesn't matter. All right, so state the range. This is a good one. A lot of people automatically think, okay, range is up and down, and they see that the highest value of this entire graph is at the y value of 1. So they say, oh, the whole thing is below it, so I'm just going to say y is less than or equal to 1, which would be wrong. Okay, it's not y is less than or equal to 1. That is wrong, okay? Why is it wrong? Because if you're saying y is less than 1, you're saying that this whole graph is going to exist at every single value below +1. And it does exist at -5. It even exists at -7 or 10, because this one goes down and it'll keep going to -10 or -7. So it exists everywhere down here. So far that makes sense. But it does not exist at 0.5 or at 0.25 or at 0.75. There's a gap right here. from the y value of 1 to the y value of 0. Yes, from 0 down, it works forever. So I need to say that my y values are less than or equal to 0, but then you could mention this additional value that it could be. So the correct range is that y is less than or equal to 0, or it can also be y equals 1. Okay, so there is your range, and you have to include both. If you write down y is less than or equal to 1, that's totally wrong. If you write down y is less than or equal to 0, yeah, that's right, but you're going to be missing that extra value of y equals 1. So you need to state it like this: both inequalities. Guys, I'm doing everything for you, right? I give you the homework, I give you the solutions, I give you videos of the homework explaining it to you. I'm giving you practice quizzes that are almost identical to the quizzes. I'm making videos explaining the practice quizzes. What? Come on, man. Everybody should be getting an A in this class, all right? Everybody. Okay, get an A. I want to see an A on that quiz tomorrow.